In this video, I'll be working through the 3.7 homework exercises on WebWork. In section 3.7, we're studying rational functions, which is a polynomial divided by a polynomial. So in problem number 1, we're given a rational function and asked to find the vertical asymptotes, and then also we have to find the horizontal asymptote. The vertical asymptotes for this graph will occur when the denominator equals 0. So to solve for the vertical asymptotes, we set the denominator equal to 0 and solve, and so it's nice to have this in a factored form. So here we have the function f of x, and to find the vertical asymptotes, we need to set the denominator equal to 0. So if we set negative 2x plus 4 times 5x plus 5, set that equal to 0, and we can set each factor equal to 0. So we have minus 2x plus 4 equals 0, or 5x plus 5 equals 0. And solving for x, we can add 2x to both sides on this equation, and then dividing by 2, we get x equals 2 is one of our vertical asymptotes. So this is the equation of the vertical line with x coordinates equal to 2. Then we can solve the second equation by subtracting 5 from both sides and then dividing both sides by 5, and you get x equals negative 1. So these are the two vertical lines that give us vertical asymptotes, and we'll see that on the graph here in a second. And then the next part, we need to find the horizontal asymptote. The horizontal asymptote is the height where the function levels out to the left and to the right. To determine the horizontal asymptote, we look at the degrees of the polynomial in the numerator. The polynomial in the numerator has degree 1. The degree of the denominator is 2 because we have two factors of x. We have a minus 2x and a 5x in our factors. So if you multiply out the denominator, you'll get minus 10x squared. So we see that the degree of the denominator is 2. Whenever you have the degree of the numerator is smaller than the degree of the denominator, then that implies that the horizontal asymptote will be the x-axis, which has equation y equals 0. So let's take a look at this graph in Desmos. So we can see that this function will have two vertical asymptotes at x equals negative 1 and at x equals 2, and we see that the horizontal line where the graph tails off onto the left and to the right is the x-axis, which has equation y equals 0. So those are the three asymptotes of this function f of x. So back in WebWork, I'm going to enter my answers as x equals 2, comma, x equals minus 1, and the horizontal asymptote is the x-axis, which is equation y equals 0. All right, let's continue with problem number 2. Problem 2 is very much like problem number 1. Now we have two factors in the numerator and we have two factors in the denominator. So we're still going to have two vertical asymptotes from when these factors in the denominator equal 0, and the horizontal asymptote will be a little bit different because the degree of the numerator and denominator are equal. They both have degree 2. Okay, so we have our function, and again, to find the vertical asymptotes, we set the denominator equal to 0, and I'm going to skip the step where I set the whole denominator equal to 0 and just set each factor equal to 0. And we get 6x equals negative 7. Dividing both sides by 6, we get negative 7/6. That's one vertical asymptote. And then adding 6 to both sides in this equation, we get 7x equals 6. Dividing by 7, we get x equals 6/7. So these are the two vertical asymptotes that occur when the denominator equals 0. So these are vertical lines where the graph kind of blows up and goes up or down. Now the horizontal asymptote is going to be different than the last problem because the degree of the numerator is 2 and the degree of the denominator is 2. So if I multiply out the leading terms of the numerator, I'll get 9x squared plus a bunch of other stuff. And in the denominator, if I multiply out the leading terms, I'll get minus 42x squared plus other stuff. And so only the leading terms of the numerator and denominator are necessary in order to find the horizontal asymptote. If the degrees are the same, in this case the degrees are both equal, then you take the ratio of the leading coefficients. So that becomes the height of the horizontal asymptote. So in this case, the line is going to be y equals negative 9 over 42. So there's your horizontal asymptote. So that's only when the degrees of the numerator and denominator are the same. Okay, in this case, both the degrees are 2. So you just look at the ratio of the leading coefficients. Let's take a look at this function in Desmos. So here's the graph. We see two vertical asymptotes, one at x equals negative 7/6 and x equals 6/7. And then the horizontal asymptote is at negative 9 over 42. So back in web work, we separate our vertical asymptotes with a comma, so negative 7/6 and 6/7. And the horizontal asymptote is negative 9 over 42. There we go. Let's move on to problem number 3. In problem number 3, we're asked to find the horizontal asymptote, and this is like the last problem where the degree of the numerator and denominator are equal. So we're going to have to look at the ratio of the leading coefficients. So for this function, we need to multiply out the numerator, and the leading coefficient will be when I multiply minus x times minus 8x. That'll give me a positive 8x squared. Now, there's going to be more terms when I multiply out the numerator, but they're not necessary to determine the horizontal asymptote. Now we see that the degrees are the same. They both have degree 2 in the numerator and denominator. So the horizontal asymptote will be given by the equation y equals, and you just look at the ratio of the leading coefficients. So in this case, y equals 8/7. And that's all you have to do. So back in web work, in this case, I have to type in the whole equation, y equals 8/7. So you have to type in the whole equation. There we go. In problem number 4, we have to find the asymptotes again, the vertical and horizontal asymptotes, but also we have to find the intercepts, the x-intercepts and the y-intercepts. Let's first find the vertical asymptotes. So this will occur when the denominator equals 0. So I'm going to set each factor in the denominator equal to 0 and solve for x. By adding x to both sides, I get x equals negative 8. And if I add 1 to both sides and then divide both sides by 2, I get x equals 1/2 for a vertical asymptote. So now when we look at the horizontal asymptote, we need to look at the coefficients of the numerator and denominator, the leading coefficients. If I multiply out the numerator, I'll get 9x times x gives me a leading term of 9x squared in the numerator. In the denominator, I would multiply negative x times 2x, and this would give me a leading term of negative 2x squared. So we see that the numerator and denominator both have degree 2, so the horizontal asymptote will have height 9 over negative 2. So we use the ratio of the leading coefficients to find the horizontal asymptote. Now, when we found the vertical asymptotes, we set the denominator factors equal to 0. In order to find the x-intercepts, we set the numerator factors equal to 0. So the numerator will equal 0 when negative 9x, if 9x minus 1 equals 0, or if x plus 2 equals 0. 9x equals 1, x equals 1/9. So here's 1x intercept. So we're looking at the x-intercepts now. And the numerator will also equal 0 when x plus 2 equals 0. Subtracting 2, this gives us an x-intercept of x equals negative 2. Now the y-intercept will occur when the value of x is 0. So if I want to find the y-intercept, I would plug in 0 for x. So f of 0, well, in this expression, the numerator is 9x minus 1, and so if we plug in 0 for x, you just get the constant terms from each of the factors. So we'll get 0 minus 1 in the first factor, 0 plus 2 in the second factor, 0 minus 8 in the bottom factor, and then 0 minus 1. So f of 0 would equal negative 2 over 8, which would reduce to minus 1/4. So here's our value of our y-intercept. So let's enter this in WebWork. We had vertical asymptotes at negative 8 and 1/2. The horizontal asymptote was y equals negative 9/2. The x-intercepts were at 1/9 and negative 2. And the y-intercept was at negative 1/4. And you could enter the unsimplified answer, negative 2 over 8 as well. There we go. Now the last problem, number 5, says to look at the graph below and find all the vertical and horizontal asymptotes. So on this function, the vertical asymptotes appear to be here at x equals negative 1 and x equals 2. So they should have a graph that has whole number answers here to make it a little easier. So to me, it looks like the vertical asymptotes are at x equals negative 1 and at x equals 2. The horizontal asymptote, it appears that the graph is leveling off. It's close to the whole number, or the integer negative 1, height negative 1 here. And also, it looks like it's getting closer and closer to height negative 1 here to the right. So I'm going to say that the horizontal asymptote is y equals negative 1. And they already have the y equals part, so we just have to enter the answer, the numerical value. Let's see how we did. We got it correct. So on your graph, it should be whole number answers for both the vertical asymptotes and the height of the horizontal asymptote. All right, and this finishes the 3.7 homework problems.